All right, welcome back, guys. Got some raw material on the floor here. Let's see if we can turn it into something useful. Okay guys, welcome back. Just to give you guys a little preface on what we're doing today. We've got some 2x2x1/4 square tube and then some 1.5 inch, 1/2 inch angle. Customer that I do a lot of work for wants me to build a frame, and I believe it's 120 inches long and I think it's about 30 inches wide. And then it's going to have some fork pockets on it, and it's going to have a conveyor mounted to it. I don't really know what they're using it for. I just know they sent me a drawing and they wanted me to build the frame, and then when the parts come in, the conveyor and all that stuff, I got to go pick that up and then I'll assemble that for them as well. So that's what we're working on today. So we're going to try to get the frame built. So to start, we're going to get the 2x2x1/4 square tube on the saw. We've got some miter cuts to make, so we'll see if we can't get these parts cut and over on the table start fitting them up. Let's get cutting. Okay, took me a while to find it. So here's the drawing. You can see that's what the frame looks like. So we've got some 2-inch square tube with some cross bracing, and then there's 2 fork pockets. So it's just a simple frame with some fork pockets. So we'll go ahead and start cutting our lengths here. We're going to start with square tube. The saw is already set at 90 degrees, so I'm just going to go ahead and cut my square cuts first. So it is 30 inches wide. So the cross pieces are going to be 26, 3 of those. So we're going to cut 3 at 26. So as I've ran the saw, I've learned how to run it the way I like to run it, which, you know, it's nothing crazy, but I'll explain to you guys what I mean. So I've got a little square piece of material here, and this right here controls where the saw comes back up to, so it keeps track of where the top of the material is, and then once this switch is re-engaged, that's how it knows where to stop so it doesn't go all the way back up. Well, I like to pull my tape against the blade when I'm pulling square cuts, so I'll take this piece of material, stick it in here, that gets this up off the blade, off the material, so I can access the blade right there. I'll pull to my measurement, 26 inches, double check, pull the material out and hit the button, and then we're cut. So that's how I like to do it. Make sure I put a bucket down so that I'm not soaking everything, because I have done that several times. And then I've got the speeds pretty well figured out here. I've probably done a couple hundred cuts on this blade and it's still working great. So that's how I know I've got the speed and the feed figured out to where I'm not burning up blades. They're lasting a long time. The material's square, it's cut, it's accurate. So we finally got her homed in. All right. Well, we'll go ahead and get these square pieces cut. When we move over to our miter cuts, we'll come back to you. All right, here comes the miter cuts. So I'm going to unlock the saw, pull this, I'm going to turn it. There is a bump stop with this at 45s, so that's why I pushed that back in, and I'm looking at the gauge and it's right on the money. So I'm going to lock that. Now I'm going to come in, I'm going to make sure that I'm past my corner, hit the green button, cut my first 45. Okay, then we're left with our little drop piece. See how good that cut looks. Look how straight that is. I have not gotten any distortion, or, you know, sometimes my old bandsaw, I could show you a cut from my old bandsaw, and some of the cuts would have like these waves in it. That's even after throwing on a brand new blade. So this one's cutting superbly. Our end pieces are 30 inches long, and that's long end to long end, which, so when I say long end to long end, that's just how we communicate in my shop. So like if I'm talking to Bridger and I say, go cut me one 43 3/4 long to long, or long to short, or short to short, depending on where you have to pull your measurement, or, you know, whatever the circumstances are. That's what I mean by long to short. So if I have a piece of material and I need a long to long, I would measure from the long side of the angle to over here, the long side of the angle. If I needed a long to short, I would measure long side here, short side here. So hopefully that makes sense to you guys. With different projects, different angles, different times that you have to cut things, I've just found that that is the easiest way for me to communicate. Long to long, long to short, long to square, short to square, whatever. And then when I make my notes, I always put one end, both ends. So if I'm making a cut list, it's clear and there's no confusion. We're gonna go ahead and cut this next one. So we've got 45 on the one end. So we're gonna slide this piece down, and I need my angles to be long to long. So I need them to be like this because it's going on the end of our frame. If I cut it like this, it's not gonna work. So I need long to long. So I could swing the saw back the other way to get that, because this is a dual miter saw, so it will miter both directions. But I've found that it's quicker, and where I'm making multiple cuts like this, it's quicker for me to just slide the material back a little bit, roll it 180 degrees, slide it back in, and that will still give us our long to long cut. So if I slide this back, roll it over, slide it back in, and now I'm going to take my tube here, I'm going to slide it out to where I can mark it. This is the other fantastic thing about this saw, is the laser. So I've pulled my material out past the saw where I can get to it. I know that I need to be 30 inches, so I'm going to make my mark. Okay, so now I know where the long side of my cut needs to be. Now here's where the magic happens. I'm going to take and turn the laser on my saw. Slide this back in. Let me see if I can get you guys a view of this. So I've got my laser on. Now I'm going to slide this in until I see my mark right there. Now the tricky part about the laser is you got to remember which side of the blade, which side of the laser your blade is on. And the laser is on the close side, so it's closest to me, so it's on this side of the blade. So I need to make sure that I put enough in there that when the blade cuts, it's going to be right on my mark. And I've done it enough now that I kind of know where the sweet spot is. So I'll slide that in, hit the green button, and she'll cut. Got our cut there. Looks good. Now we're going to check the measurement. Okay, so let's see how we did here. We were shooting for 30. I'm going to see if I can show you guys this. It's probably hard for you guys to see, but it's right on the money. So that's the beauty of the way this miter saw works and the way the laser works in correlation with the mitering capabilities. It's just awesome. For doing miter cuts and building frames like this, I had to tack up some handrail yesterday and fit it up, and it went awesome. So I'm super impressed. Anyway, I wanted to show you guys how I run the miter capabilities on the saw. So we'll get the rest of these cut, We'll get them over at the table, and then we'll get them ready to prep. So when we get ready to prep them, we'll come back to you over there. Okay guys, we're back over here at the table. I've wiped all my parts down with a rag just to get the oil, bandsaw cutting fluid off. And now we're gonna go through and we're gonna bevel these. So we get all the corner joints beveled. I'm not gonna bevel the cross bracing. There's no need for that. But the ones on the corners, I've gotta bevel these. So I am using a hard disc for that today. Anytime I'm welding on structural steel that's 1/4 inch thick or higher, I usually just use a hard disc because most of the joints in that situation are just going to get covered up with weld anyway, and I can hog a lot more material a lot faster with a hard disc than I can a flap disc. So I'm using a hard disc today. We'll go ahead and get these knocked out. All right guys, we got our frame parts all set up here. Got my Fireball square out. It's Fireball 30. So we're gonna go ahead and fit that up using our Fireball square. And I'm just gonna do like I always do. I'll start on one corner and I'll just work my way around. And if your cuts have all been made correctly, correct lengths, correct angles, by the time you get around to the other side, you shouldn't have an issue fitting this last corner back up and having everything be really close to square. I've got some of the Manus clamps out too, clamping this down. I like to flip the Fireball, I don't want to say backwards because I know that it's designed this way, but I like to flip it so that I have this gap in the middle here where I can tack and not have the corner of the square in the way, because I like to tack on the corners. You guys know I've told you this before. I like to tack on the corners so that if I have to cut it apart, if I have to get a zip disc in there, I can. So we'll go ahead and tack this up and see if we can get it all fit up and squared up. Here we go. All right, so we're down here at the other corner, and I do have dimensions I need to hold. So I am gonna just check this and make sure that we're still good. It is kind of hard with these large radiuses on the tube to get it right where you want it.
It's time for today's super cool tool.
For today's super cool tool, we've got, I don't believe I've had this on here. This is made by Flange Wizard, obviously, and it's got a magnet on the back and it's got a magnet on the end of it. And what this is for is it'll hold your tape measure for you if you don't have someone around to hold the end of the tape measure. So I'm going to stick this down here at the end of the tube. Hopefully you guys will be able to see this, but I'm going to run my tape down there, and because it's magnetic, there, it should butt right up against that. Woo! Freaking right on the money. Okay, so I'm gonna get some tacks on this end down here. So there's multiple ways that you can use this. So the magnet on the end, my tape can hook to that. So if you've got a piece of tube and you've got a mark on it and you want to hold the end of your tape to that, you can put this, it'll stick to the tube, put it right on the edge of your mark, snap your tape measure to it. Obviously you want to make sure you're either pulling or pushing in the right scenario so that your measurement's accurate. But I use this quite a bit because I'm out here by myself so much. So I'll leave a link in the description, but Flange Wizard makes awesome tools. There's multiple tools out there. There's multiple tools that I have here in the shop, But the tape measure assistant tool, whatever you call that, this is my assistant, that right there is a good one to have if you're working by yourself a lot. And it also has a level on it. I don't really know if that's just so you can use it as a level. I actually have used it as a level in a few situations, so pretty cool tool. Anyway, check it out. Hope that helps somebody out. Let's get back to the project. I think it's a thing of beauty. And my measurement is right on the money. Okay. And I'm gonna flip this around. Okay, everything looks good there. So now we got to get our cross bracing tacked into place. So I'm gonna pull up the drawing, check the measurements there. I'm sure the one goes center, but then I need to double check on these two. 29.5 from outside to outside. There's a big bend in the middle of this piece of plate, which is super fun. One of these days I'm going to invest in a large fireball table. That way I'll know it's always flat, and stuff like this on a table this size, if it was a fixture table, would be amazing. We're ready to start welding this out, so I'm just going to go through, hit the corners first like I always do, get those locked down, and then I'll probably flip it, hit the other side of the corners, and try to keep everything square. So we'll just go through and weld all these up, and then we'll start bouncing around on the inside. Once we get the structure all welded out, we'll come back to you, because then we got to get the fork pockets mounted on here, and there's some stuff we got to do to the fork pockets before we get them on here. So let's weld this out and we'll come back to you. Hey. It's just about lunchtime, so I'm going to take a lunch, let this cool. When we come back from lunch, we'll go ahead and start working on the fork pockets. We'll catch you guys after lunch. Alright guys, so here's the next phase. We've got our 3x6 by quarter rec tube here. We cut those at 36, and the drawing calls for a hole to be drilled on either end, 3 inches in and then center. The purpose of those holes is we're going to weld a nut to those, and then they're going to screw a bolt in there, and they actually use those bolts to level it for when they set it on the ground. So we're going to get the mag drill out. We're going to set the mag drill up and drill these. That's the next order of business. So I'm working on getting them laid out. I've got the first one laid out, but just like usual, just take my tape measure, my nice sharp soapstone. I'm going to grab a hammer and a center punch. We'll go ahead and punch those, and then I'll grab the mag drill, get it all set up, get a 7/8 annular bit set up in it. We'll come back and drill these. These drills are incredible, and I bet you I've drilled thousands of holes with a Hogan mag drill, because the company that I used to work for, he had a couple of them. For years and years, he had the same mag drill. It had literally been through a ton of holes. The Hogan mag drills are a testament to durability, and they just run, and they do a good job. They cut a precise hole. They're built for this kind of thing, and I am a huge supporter of Hogan mag drills because I've seen what you can put them through, and they just keep working. We're going to try our anchor lube on this, and then I always put earplugs in because these are pretty stinking loud. The anchor lube worked good. I like that when it heats up a little bit, it almost melts just a little bit, and I feel like that makes it flow a little bit better. We're going to go ahead and jump over to that other one. We'll get the holes drilled in that one. When we get ready to weld the nuts on, we'll come back to you. Okay, so here's the next step. We got the holes drilled, and I've got some 1/2-inch nuts here. I'm using 1 bolt just to help me fit these. But what I'll do is I'll actually slide this halfway down in there, and I'll slide it in so that this surface of the nut is flush on the inside. That way it doesn't interfere if they've got to slide the forks in there. And then on the top, I'm left with enough material that I can put a nice weld around that. So when I weld these up, I'll just use dual shield, and I'll just trigger that up. The first skid that they had me do, they wanted me to tap the holes. And I told the engineer, we have a pretty good relationship. I told the engineer, I said, I can tap them if you want. I'll do whatever you want, but it may be better if we tack weld a nut in there. That way, if the threads get damaged or whatever, all you've got to do is take a zip disc, cut the weld around that nut, smack it with a punch, drop a new nut in there, weld it out, and then you're back up and running. So there are certain situations where I would say tapping is better than welding the nut in, but in this situation, I think we're better off welding the nut in, because if it gets damaged, it's going to be a lot easier to replace. If you were to screw up the threads on a tapped hole in this tube, you have limited options. You've either got to drill it out and go with a bigger size the next time. You could drill it out and then add a nut the next time anyway. So if we're already going to do that, it just makes more sense to me to just start with a nut. So that's what we're going to do. So I'm going to grab my stinger and my hood. We'll go ahead and get these tacked in and welded out. Okay, so I'll get me a tack on there. So once I get a tack on there, I like to take and get this leveled up and then get another tack on it. So once I have it tacked into place, now I'll just go all the way around it and trigger that up. And I try not to be too generous with the size of these tacks. We don't want to melt the nut away into the threads. Okay, so I'll hit this with a wire wheel and then I'll show you guys what we're left with here. Okay, so there's what we're left with. And then you can see that bolt screws in there just fine. It doesn't protrude, the bolt does, but the nut doesn't protrude past hardly at all. The other reason I show you that is that may be an option for you guys that don't have the equipment or the means to tap something. So let's say you run into a situation where you need to tap something, and I understand in not all cases will this work, but in some cases you may be able to just drill a hole and tack weld a nut in there and be just fine. So hopefully you guys got something out of that. All right, I'm gonna go through, get the rest of these welded in. When we get them done, we'll come back and move on to the next step. Okay guys, we're over here at the burn table. I've got some gussets drafted up. The drawing calls for a gusset on the outside of the fork pockets welded to the tube. So we're gonna burn 4 2.5 by 2.5 by quarter gussets. We'll get these burned and then we'll go over and start fitting them up. So I went back and checked the video, and I think it must have muted on me or something, because I think a couple videos there didn't have any audio. So I want to run through this with you guys. So I put a lot of heat into this. I didn't mean to, but you know, I kind of was worried that this was going to happen anyway, just because of the design. You know, when you weld fork pockets like this onto a frame like this, and you put that much heat into skinny material like that, you're going to end up with a banana. Well, guess what? That's exactly what we got. So what I've done is I've got a come-along wrapped around it. I've got the crane rigged up on the other end, and I'm lifting it up. I've got as much pressure on that as I can without lifting the table off the floor. So, and it's quite a bit of pressure. I'll show you guys how much curve is on it right now. I'm going to leave it like this until it cools, in hopes that it will bend it back to shape. So let me give you guys a look. Hopefully you can see how much curve we've got on this right now. Oh yeah. Oh yeah. There's plenty of curve on it. Okay guys, so I just want to mention something real quick. So I got a text message the other day, and it was from someone that I truly respect. I've worked with him in the fabrication industry for a long time. I know the guy really well. I consider him my friend. He reached out to me, and he had just finished watching one of my videos, and he said, "Hey, I want you to know that I think it's really cool that you put your mistakes in the videos." And he said, "Don't ever change that." And he said, that's one of the things I respect about your videos, is you leave that in there. We've kind of had the conversation back and forth a couple of times, But I ended up responding, and of course I thanked him. And you know, it means a lot, especially when it's coming from somebody that you used to rub shoulders with and worked with in that industry. I told him how much it meant to me, and I just told him, I said, you know, I'm a firm believer that if people really want to get better at welding, if they really want to learn, this is the kind of stuff I have to show, because this is real world. And there's plenty of people, plenty of armchair quarterbacks, plenty of keyboard warriors that want to sit in their recliner and say, well, that was dumb, you should have this, you should have that. And they want to tear you down and talk about how dumb you are because you made a mistake. Well, guess what? I'm making mistakes because I'm out here doing it. And mistakes is just part of the deal. Usually, when you make mistakes, that's the times that you learn the most. And these are the kinds of things that I get people commenting all the time. You know, thanks for showing that. I really appreciate it. Because this really happens. It happens all the time in fabrication. And so if you really want to learn some skills, if you want to learn how to be a better fabricator, you better learn stuff like this. First of all, the first thing you can learn from this is you can't put too much weld into anything that you build, or it's going to turn into a banana. That's the first lesson. And there was no weld spec on this drawing, so I just went with what I thought. And obviously it was probably a bit much. But here we are, hopefully fixing it. So the other lesson is, if you do end up in this scenario, this is not a do or die thing. It's not, oh, now we have to cut it apart and start over. There's ways to fix it. The other thing I could do is I could heat it up with the torch and then take a wet rag and cool it with the wet rag, and you'd be amazed at how much you can get a part to move when you do that. So I'm going to try this first because I really think this is going to fix it. It's still pretty hot, but once it cools, you know, it's still got heat in it. So I figure with heat in it, if I could get it flexed the opposite direction and leave it that way as it slowly comes back down to temperature. You know, there's a lot of science that goes into the molecules and what they're doing with different temperatures, and you're flexing them and you want them to stay a certain way after it cools. But I just wanted to show this, and I wanted to share that with you guys. That's why I show this. I don't show this kind of stuff because I love being torn down or critiqued or whatever. There are a lot of constructive comments where people throw out friendly suggestions, and I appreciate that. I'm just saying, the people that just want to sit and critique you and tear you down and tell you how dumb you are for making a mistake, guess what? You strap your boots on, you get to work, you're going to make mistakes. The important thing is, when you do make mistakes, are you learning anything, and do you know how to fix it? Those are the two most important things, in my opinion. So that's why I show this stuff. I just wanted to share that with you guys. I will continue to show this because it's real world. So this is the world of Freedom Fab right here. All right, when this cools, we'll come back and see how she did. Okay guys, I've let it down. Let's see how we did here. Okay, so there is still a little bit, you can see, but it's only about 1/4 inch. And if I lift up on it right here, there's quite a bit of flex in that, so we'll be fine. Once I get the conveyor on there, we can clamp it together and it'll be just fine. So I just wanted to share that with you guys. I didn't hear from the customer, so the parts must not have got here today. It's currently Thursday. Everybody's off tomorrow for the holiday. Speaking of that, hope you guys have a really happy 4th of July. Hope you guys get to spend some time with your families and enjoy the huge, tremendous, amazing blessing it is to live in this country. I thank God for it every day. So hope you guys enjoy it. Happy 4th of July. We'll catch up to you when I get the parts, and then we'll continue on with this project. All right guys, welcome back. I almost forgot to record this last little bit of this video. We just went and picked up this conveyor. Finally came in to the customer. There was all sorts of issues. It was a big fiasco. I guess it was lost in shipping or something. They had to order a second one. Anyway, it was kind of a crazy deal. So it's been a few days. I was just kind of waiting for them to call me and say, hey, the conveyor's here, come pick it up. So we got the conveyor. You can see we've got it set in place. I did take and bolt on our end pieces here. I don't remember if I got video, but I drafted those up and CNC burned those on the burn table. Those are bolted up. This is kind of a backstop so that whatever they're transporting doesn't roll off the end of the conveyor. We got those on. So now all that's left is we got to mount the conveyor to the frame. So it fits beautifully on here. I'm actually just going around and getting it centered. And then I've got it clamped on all four corners. My plan is there are, what, 1, 2, 3, 4. There's 4 holes on either side of this conveyor. Okay, so you can see there's a few holes here that is a through hole. So it's going to be hard for me to transfer punch this because I can't get my transfer punch down through this top flange. But this one has a hole through the top and the bottom. So I'm actually going to use that as my mounting hole. So I'm going to transfer punch through there. I'll transfer punch through both of these in the center and then this one on the corner. And I'll do that to both sides. And that should hold it in place. So this is a transfer punch set. I actually have 2 sets of these. This one actually goes from 332 clear up to 17/32. And then the other one I have goes up to, I believe, 1 1/8 inches. But all you got to do is search transfer punch set. I can leave a link in the description for these. So anytime you have a pre-drilled hole like this, you just go through and you try to find the one that just barely fits in the hole. I'm going the wrong direction here. Like that one. Okay. And then I'll drop this down through. Okay, so on this one I actually had to push this hex piece for this conveyor in just so I could get it past that. But it does go down through all the way. So now I'll be able to smack that with a hammer and get my mark in place. And I can see that it's good. So now we'll move to the next one. Now this is gonna ensure that these holes line up perfectly. For these ones I'm actually gonna have to pull that roller because that side isn't spring loaded, which is not a huge deal. With these rollers, there's one side that's spring loaded, so you just have to push that in till it gets past that hex and then pull it out. Whew. Ooh, that one fits. Okay, so we've got 4 holes on either side. We're going to get the mag drill out. We're going to drill these all the way through, and then I'll be able to bolt this on. So we'll unclamp this, we'll swing it out of the way, we'll get the mag drill set up, we'll drill these. Once we get all that done, we'll come back and we'll show you guys when we're ready to bolt it up. I think I've mentioned it before, but I like to go through and circle my center pops with soapstone or a Sharpie, just so I know where they're at. Sometimes they can be hard to find. So if I haven't mentioned it before, the depth of cut on the bits for this drill, the max depth of cut is 2 inches. You can get 1 inch depth of cut. I always just get 2 inch because I just feel like you're better off having a 2 inch depth of cut than a 1 inch, unless you have some sort of a special circumstance where the surface you're drilling is 3/4 of an inch higher than the mag base, which I haven't ran into that yet. I typically just run the 2-inch depth of cut. This is 2-inch square tube. So we'll go ahead and we'll keep drilling these. We're gonna get Bridger on the mag drill. He's gonna drill this. I'm gonna go start getting hardware rounded up, and then we'll come back when we're ready to bolt it up. Okay guys, we got this roller pallet done. The last thing we had to do was take and cut a couple pieces of angle for the side guides and bolt those on. So hardware was included. We just cut them to length and got them bolted up. We also took a grinder and hit all the sharp edges and sharp corners so that somebody doesn't get a laceration. So I'll give you guys an up close look here. Okay, so we went ahead and rounded those corners on the angle. There was some sharp edges on these. Took those down. See, everything's bolted up. That's going to be another project in the books. One thing is for certain, I still feel like I learn stuff on the daily, especially where I'm doing it full time now. I feel like I'm learning things every day, and I absolutely love that. I love to learn new things, so if I could give you guys some advice today, learn something new. If there's something you don't know how to do, research it, try to figure it out. Anyway, hope you guys enjoyed it. Thanks for watching. See you on the next one. I'm happy to do it, and I created the super tool goodness. They're this